Welcome back. Now let us do the hands-on on ARIMA and 145 we are getting data fresh, 146 converting to data table, 147 converting column name to uppercase, 150 we are making to MSTS object so that we can work with time series algorithm, and this is the basic plot which we have already seen earlier. So this is the basic plot we have already seen earlier. Okay, this is the way to really work out. Okay, and season plot, let me show you. This is one thing new. So what it is trying to do, it is doing for each of the month across year, that what is the trend of each of the month across year. If you see that almost only the February, this March has really gone up, but March has a very different. March thinks it has really gone up, and May has also been different. August, September has been also a little bit different. October has been also different, and so on. Otherwise, it looks good. Most of the things, most of the data across year, if you see that only for March around these 3 years, and May these are the 2 years, June it is 2 years, July 2 years, and August 2 years, and then September 2 years, October this year, and so on. So around 2-3 years, almost. See, if you see, you take any month across almost all the years, they are having the similar pattern, and only 2-3 years are the exception. So this is the looking the seasonal plot. Okay, now that is also called month plot. So let us go and do the 161 and 162 in one go. So across month it looks okay. Almost every year every month is looking same, so not much difference, except there is a little bit difference of this August, May and September. This is the having little bit difference. And bottom side all looks okay, only the June has come down. So May, June, July, these are the little bit difference. So this is the way you should analyze it. And let us see that last 4 lag. Lag means what? Lag means the difference of the current with previous one. That become 1 lag. 2 lag means the current with 2 previous difference. So let us show you the 165. Here I have taken the 4 lag. So this is the lag 1 means the what is the correlation. So definitely it is the very high. Okay. Lag 2 have some, but not that much. Lag 3 is again it is getting a sparse. Lag 4 is getting further sparse. Okay. Okay. Now in the concept you had seen that first of all, let me show you again. So you have seen over here that we can do either manual or automated. So first we'll try to do the few things manual so that at least we understand the concept, and then we'll learn the automated. In case of actual project, you will be working in automated way. The manual is just for clearing the concept and you are aware of the concept behind it. So let us do the few things for the manual, like to test whether your data is stationary or not, and this is called decay Fuller test. Okay, so let us run the 168, and it has given the p-value 0.53. So what is the meaning of that? 0.53, what is meaning? That we do not have enough evidence to reject the null hypothesis. So we are taking the null hypothesis, and as soon as we take the null hypothesis, it means this data is stationary, yeah, or not stationary. So we are saying null hypothesis we have to accept. It means we cannot reject the null hypothesis. So null hypothesis for decay Fuller test is not stationary. So this data what we have, it is not stationary, and you can definitely see. Let me show you from the decomposition part. We have already done 171 to 172. We are running it together. See the trend. It has some trend. It is going up and coming down. That is why it is non-stationary. Okay. Good. Now, a few things. ACF and PSF. Let me run it first, and then I will show you. 175 to 178. I have run it in one go, and see what it does. In case of ACF and ARIMA, that if you recollect, this is having the seasonal, and this is non-seasonal, and this is the seasonal. So what it does, that ACF gives you the value of MA. MA is over Q, and the D gives you the how much difference you take it to make the data stationary. And PSF, that is this one. PSF gives you for the P part. Okay, this is from the manual point of view, but if you do the automatic, everything is selected by algorithm on its own. You don't have to worry about, and that is why for learning point of view, I am trying to show over here. And if you see the significance 1, 2, there are two significant. So there is it means Q equal to 2, and here it is 1 significant. And some places I have seen the people taking negative also, that become the 2 significant. Yeah, equal to 2. Okay, in that case, and D is a difference. Generally, if you try to take the difference of 1 or 2, then it becomes stationary. So D generally 1 should be good enough. And this is the how you can figure it out, value of P and Q. Okay. Now there is also another concept, that is the auto things. Let me run the 181 first, then by the time it is running, I will give you. See, 181 is something called automated, and this is what you have learned. This side, right side. What it does, it takes care of making the data stationary, finding plotting ACF and PSF, finding a P and Q and or both for non-seasonal and the seasonal, and then it try to choose the model which is having the minimum AIC. So it is automated, and if you see that it is running with all the options, and if you see these options, this is having the option over here. If you see the documentation of auto.arima, these options are already over there. Okay, so it takes that this is our data, trace equal to true, so that you can see this kind of output. Stepwise false and approximation false. It will give me the proper. And if there are a lot of the other parameters which are useful and you must know, and I will encourage you to see the documentation of auto.arima. You see, if you can see, I have just, if you see the tool tips, you can assign everything. So right now it is taking the by default everything and going ahead. Okay, so it has done it, and the best model it has find it out, this one. So okay, no problem. So it is saying 5. I think it has like a 1, 2, 3, 4, 5. It has come to this point. And but one thing, it takes the combination. If you see, you can also try to see that why this set 2 and 1, it is not good. You can see the wherever it is, and see that it is taking with minimum EIC. That is what one of the condition of good model. That is the condition of one of the good model. Okay. Now I think let us see this. I'm trying to run the 182 to see this one. So this is the model. It has got the best model. And C5 means MA. MA this MA1 and 2, this coefficients internally it is able to calculate. and other things are not that much, but AIC need to be taken care. See, alone AIC does not have any meaning, and the full form of AIC is A for Akekine, I for information, C for criteria. Akekine information criteria, and this is useful for comparing two models. If whichever is having less is the good model. Okay, so this is the way we select the model. That's all. Thanks for watching it. See you in the next one.